In this video, I will discuss the LeNet-5 architecture and explain how we can create an architecture that is same as the LeNet-5 in Tensorflow Keras. So the first thing we do is import all the libraries, and then after that I will use the MNIST dataset to create training images and the corresponding training labels. Now these are images containing digits from 0 through 9. So our data set is now ready. Our training images are 60,000 in number, and there are 10,000 images in the validation set. Yes, and then we can randomly visualize one of the training images and also print out the label of that image. So we can see that this image is 4 and the corresponding label is also 4. So we have the training images ready. Now we're going to prepare those images for by rescaling for training, and then also we're going to convert the labels into categorical labels so we can use cross entropy based training. So then after our reshaping and converting them to categorical, our labels are now in this format where each label is a 10 size vector. So then here's the LeNet-5 architecture, the model. We start with conv2d, 6 filters in the first layer, each of size 5 by 5. And then in the second layer, we have max pooling with a pool size of 2 and stride 2. This means it's going to skip 2 steps at a time when calculating when computing the max pooling. So that's the first layer. In the second layer, once again, we have a conv layer with 16 filters, 5 by 5 each, and then followed by max pooling. And then we flatten it out. In the third layer, we have a dense layer with 120 neurons here with sigmoid activation. And then in the fourth layer, we again have another dense layer with 84 neurons, sigmoid activation. And the last layer is a dense layer with 10 neurons, and we use activation as softmax because we are predicting the probability of 1 out of 10 classes. So then we can compile the model using categorical cross entropy. So let's build this. So we build this model, and after the model is built, I can click model summary to see how the model looks like. So here it is. It has around 44,000 parameters, and then I can simply do model.fit with training images and training labels. I can use the training images and training labels themselves and simply split it into 80% training and 20% as validation, so that the 10,000 images that we had earlier can be used as a test data set, and then I can do the training. So this is how we can create a neural network that's same as the LeNet-5 architecture and train it for tasks like MNIST digit recognition. So this is running. It looks like I did not select the runtime as GPU. So if we do have GPU here. So this training should start running. There we go. So one epoch is only around 11 seconds. It should go down, and here it is. The training has already started. As you can see, after 2 epochs, the accuracy on the training set and the validation set is already around 97%.